Okay, so the motor control schematic, essentially what we're showing here is we're showing a schematic view of how each of these motors work. So we have our main 3-pole breaker that's bringing in the 3-phase electricity to our motor. Remember, we have only 3 conductors because it's a balanced load. We don't need more. We don't need a neutral. If you look at the way that the schematic is laid out here, what we have is we have the starter mechanism, which is actually separated from the 3-phase motor itself. And so the starter actually runs through a transformer. So we have the transformer which takes 208 volts, that's the line voltage, and converts that 208 into 120 volts. So now we can use a regular switch. We can use a rated 120 volt switch. That's the purpose of that. So we're taking 2 connections between 2 lines, and we're running it through a transformer which is going to convert 208 volts into 120. Okay, so we're not having to size our switches based on 208 volts, which would be more expensive switches. We can use a smaller voltage switch. So if we follow the live, this would be the live side, this would be the neutral side. If we follow the live side, we have what comes through what are called overload contacts. So these overload contacts are just basically going to check to make sure that we aren't in an overload situation. And if we are, it's going to remove the, it's going to basically break the electricity. It's going to break the circuit at that point. We have a stop mechanism here. Now you notice that you guys have already drawn some of these symbols. You've already drawn this type of symbol. It's a push button stop push button stopper is what it is. So this is like a kill switch, right? So if there's no, if this circuit is broken, then there won't actually be any power running through here, and it won't actually, the motor won't run. Then we have a start switch. So what the start switch does is when you push the start switch down, it creates a temporary, because this is usually on a spring or something like that, it'll create a temporary connection which now comes in, activates the starter coil, which is going to start that motor up. It's going to try and get that motor spinning. And once it's started up, we'll have these holding contacts, which will, electricity basically gets rerouted once it's started up and holds the electricity on. That's what the holding contacts do. They hold that electricity so it's now running until the stop button is pressed. The minute the stop button is pressed, the electricity stops flowing through the holding contacts. You now need to reactivate those holding contacts by restarting the whole process again by pressing the start button. Okay, so that's just essentially this is just the starter mechanism separate from the actual motor mechanism. And so this starter might be in a separate room, might be in an enclosed container, and a lot of times what happens is they dumb down the voltage on it, so they make it lower voltage, so that you imagine if you have 208 volts, if you can't actually push the start button quick enough, you're bringing those contacts closer together. At a certain point with 208 volts, there's going to be enough voltage there to overcome the resistance of the air, and you're going to get arcing. You don't want that to happen. So they bring it down to 120 volts, and now, because the voltage is a lot less, you can actually close those contacts a lot quicker without creating an arc situation. So that's why the 208 to 120 volt transformer there is so that we don't have to worry about arcing, we don't have to worry about explosions. 3-phase motors, I mean, you can get 3 phases that are quite powerful, and if you have a 3-phase motor starter, those things, the arc on them has been so powerful, it's been known to blow people up and actually kill them. So this is a safety mechanism as well as a convenience item. So these starters might be, again, in the motor control center, which is separate from the actual motor. All right, so now we have our main contacts. Now this would be part of the starter coil, would probably connect into here. We don't show connections to it, but the starter coil would likely connect the main contacts to get this 3-phase motor running. And the last thing we have is we have some overload relays. Now the overload relays might be connected to the overload contacts, and what it's doing is it's checking to make sure that you're not in overload. Those relays are if you remember back to electromagnetism, a relay, once you have electricity running through a magnet, it pulls down the lever of the relay and it holds that relay in place as long as there's electricity flowing. The overload contacts, if one of the contacts gets into overload, it will release that magnetism. It actually breaks the circuit, and now your relays go back into normal position because there's no longer an electromagnetic field pulling the lever down anymore. Okay, so that would be an example of what's happening. So you basically just need to redraw what you see here. Nothing fancy, just you've got a lot of these symbols already. You've got the transformer. Use them from the symbols that you drew in Electrical 220. They should be hopefully in your drawing already, so you can just use those. We also have the single line, this is called the riser diagram, and again, you probably have a lot of these already drawn. So what you're going to do is you're going to work your way from the right-hand side to the left-hand side. So we already have the information about these panels now. We've got the panel 3, whatever you have for panel 3, whatever you determine, that's going to come from your panel schedule. 225 amp breaker, 225 amp busing, and you've got your feeder size here, and you know your total wattage for 3-phase is 175. You're going to fill that information in. So you're going to have 175 amps, 12208 3-phase 4-wire. The feeder is going to be the same size as the feeder that you use in the top of your panel. Same with the conduit. You're going to size the conduit as well. So you're going to have 4. In this case we have 2-aught, so it's going to be 2-aught American wire gauge RW90. And let's say you come up with 27 millimeter size conduit, you're going to put 27C. And then you're going to also put the 3-pole breaker, so 225 amp 3-pole breaker. That's just the example we use. Your value is going to be different. You should not have 225 amps there. And then you're going to repeat that for panels 1 and panel 2. Whatever you get for panel 3, repeat it for panel 2 and 1. So it's the exact same thing 3 times, but you're only doing 1 calculation. Now your motor control center, once you determine what's happening with your motor control center from your check assignment, you're going to fill that in as well. So you're going to fill in the amps, you're going to fill in the conductor size or the feeder size as well as the conduit size, the breaker that you require, and your motor distribution panel comes from your motor schedule. So once you've finished your motor schedule, you've finished the feeder, you've finished the breaker, the busing as well, the breaker and the breaker size you're going to need for all 3 of those. You fill that information in here, and you fill in the feeder to the main distribution panel. So you work your way from the right to the left. That's really what you have to do. This value here, go back to the instructions here just to make sure. I've got it again. The single line riser diagram, we've got all the instructions of exactly what to put in. Gives you information how to fill in the transformer, and it actually even gives you the text to the left of the transformer. So it's a little bit different, but that'll be the text that we use at the left of the transformer. It's not the same as on the right hand side here. I give you this information in the instructions. So just follow step by step the instructions. Once you get your check assignment finished, then you'll have more information that you can now fill this out.